And we're live. Hello, my friends. Thank you for joining us for today's webinar. It will definitely be a fun one, and I think a topic that doesn't get the amount of love it deserves, which is session takeovers. It's got a lot of names: session takeover, session replay, session hijacking. People usually use them interchangeably, though they do mean slightly different things. I am Nick Ascoli. I'm the Director of Product Strategy here at Flare, and with me today is Jason Haddix, who is our Field CISO. Jason, you want to say hi?
Hey everyone, how you doing?
And let's get into it. So first of all, I want to talk about what sessions, cookies, and session tokens are. Also, it also goes, it's important to say, these are terms that in the industry generally, you will see thrown around interchangeably, but they do kind of refer to different things. So a session is often what's used to refer to the state of a user. And the duration of their actual time on the website. What do they do in a given session when they're visiting the site and when they leave the site, log in, log out? What is actually happening between the client and the server? The duration is referred to as a session, and there's all kinds of interesting tracking that goes on around a session. The other thing is a cookie, and a cookie is just it's literally a value which in most situations takes the form of an actual file that maintains like hard-coded values that the browser is adding to a list or changing based on a website. So a website will store values associated with the user it'll pass it to the user, to the client, who will store them on the device. It's saving things like their settings, whether you're in dark mode or light mode, and then sometimes more interesting things like a session token, which is like a value that's communicated on the server side to their auth server to allow you to resume what you were doing on the site when you last left. So that's why when you close out of Facebook or you close out of Amazon and open it up 2 weeks later, you don't have to log in again, because one of those cookies it saved was a session token or a session cookie. The terms are not strict there. And that is telling the server that your session on the website is still active. And the session token itself is the important one there. So there are lots of types of cookies. Not stealing, if you steal all of a browser's cookies, only a few of them are going to mean something to a bad guy. Most of them are just settings and configurations and little tracking things that ad systems use. But a few of them will be an auth session, an auth cookie, or a session token, and those are actually the most impactful things to leak. Jason, do you think I represented cookies correctly?
Yeah, absolutely. I mean, your cookie is your thing that represents who you are after you log in, right? So you get your cookie, your session token for a website after you log in. So you put in your username and password, you do your two-factor authentication, and then the website gives you that token, or that cookie, which is a session token. And then it allows you to stay logged into things like Netflix forever, right? Because you have that cookie stored in your browser. So you don't have to re-log in every time you go. When you visit Netflix to go to like a new show page or something like that, it just checks your browser. And it's like, hey, does he have the right session token? Yep. Okay. Let him in to watch, the new season of whatever. And so that's why it's one of the most targeted things, both in bad guy world and in pen tester world, to my world where I come from, red teaming and pen tester. We try to steal session tokens and session cookies all the time. Yeah.
Cool. Now let's talk about what people actually do with those sessions. And by people, I mean bad guys, red teamers, or threat actors. So first of all, to take over a session, you first have to find a session. And the easiest way to do that, other than like infecting a device with your own malware or buying malware to do it, and then like post exploitation, sending compromised cookies back to yourself, is buying them from someone else. And there is a rich network of marketplaces for stolen credentials and stolen cookies that exist in the world of cybercrime. There are hundreds and hundreds of these marketplaces, and the people who operate them are buying access to, you've heard of Redline Stealer or Meta Stealer or Raccoon Stealer or Luma Stealer. These are all, some have come and gone already, but these are all overwhelmingly affiliate programs. So the Redline and Meta org, they maintain all the infrastructure for the malware, They keep it alive. They make sure the panel works that the users log into. But who's actually out there infecting people is users of Redline. So they'll create an account. They're now considered, affiliate is a common word. Customer is also common. And they're getting a portable executable or a link to a download from the person who operates the malware, and their job is to spread it. So they're creating fake Google ads for a website called Java, but the A is slightly different. It's in some different character value, but it still looks like an A. And they'll create a sponsored Google post, and then when people are going to install Java, they're actually installing your package or brew.sh, or those are just some examples of what we've seen recently. Or they'll create YouTube videos with like, here's how to get free GTA 5 or the newest Minecraft mod. And in the description to the download link, you can download the mod, but it's laced with whatever the flavor of Steeler is.
Yeah, malware.
So,
yeah.
yeah.
This one's really interesting because I know plenty of hardcore security person whose kids have actually done that, right? Like torrented something, clicked on a link out of a website on a personal machine, and then managed to get the personal machine that had at one point logged into corporate resources, stealing the cookies, and they'll end up on places like this. You'll see the one on the right is more dark webby. I don't even know if that's a word, but dark webby. And then the left ones are actually Telegram channels that these things get sold in these days, because Telegram is a little bit less regulated. And so these credentials, when they get stolen from you, end up either on the dark web or on these sale Telegram channels from these distributors or these sellers. And yeah, it's crazy.
Yeah, and they're like to the tune of weeks and days. They're leaking. They're compromising thousands of devices. The campaigns are really successful, and on a monthly basis, it's hundreds of thousands, millions for some really effective programs. And basically, the users have their own panel they log into, and every time their unique executable or unique link gets a victim, they are sent the credentials. It doesn't go to Redline directly; it goes to the user, and then the user will package those up in a big zip or post them directly into Telegram as like on a per device basis. And they will sell those credentials by bulk, and they'll sell the access to the machines in bulk as well. So distribution works commonly in three ways. There's free sample channels where those groups will just give away, every week, a couple weeks old, already mostly burned and used accounts, which still have all kinds of value. We've seen lots of major attacks come from people who've never paid for Steeler logs. Archive channels, and these are where you're paying for access, you're paying for a membership to the channel, and they're giving you a daily zip that's like, here's the 10,000 infected devices from yesterday, here's the 12,000 from the day before. You get a fresh crop of infected machines every day. And then you also get a ULP. So maybe you don't want to browse through the file system of all these devices and find parse out the password files yourself. A ULP is a URL, login, and password. And it's just one big file of all of the credentials stolen from all of the victim devices. And I'll give a demo where I show you what it actually looks like on the victim device, like where the interesting files are coming from. But we'll start with something simple. So let's say you're a member of a Steeler Log Telegram channel, and every day you get your daily zip. When you open that zip file, it's going to be a bunch of usually just random characters in their own zip files, maybe tens of thousands of them. Each of these represents an infected victim. Now, you don't have, like, as a person buying these, you don't have like remote access to this victim. You just basically have a copy of what was on it, at least that the malware was able to grab. So when you open one of these zips, you're presented with like the footprint of the device that the malware stole. The system info file is going to give you recon data about the device. This is like the whoami command, the system info command, maybe an ARP command. This is like just kind of the malware automatically getting the lay of the land. It'll take a screenshot of the device at the time of infection, which are usually sometimes very sad to look at, sometimes very funny to look at. There are people like immediately running AV because they know something's wrong, but the AV, it's sometimes very advanced AV, has been evaded by the stealer, or it caught it after exfil, which does happen sometimes. And then the passwords.txt file. This is usually what people are there for. Most people buying Steelers, because they're just like recycling accounts, or they're access brokers trying to find interesting ways to get in. but more people buying stealers are just kind of off the shelf fraudsters, and then less of them, but the ones we worry about more are the people doing more advanced things with the credentials they find in the logs. But the passwords.txt file is all of the passwords, the URLs, logins, and passwords stored by the browser's own password managers. So when Chrome asks, do you want to save this password? And you click yes, that is saved on disk. That is saved to your device, and Chrome can access it. So like these stealers will create a sub-process of Chrome maybe, and then depending on when this stealer ran, because there's like device-bound sessions that Google implemented that stealers have learned to get by, they'll create a sub-process of Chrome, inject into that, and then they have the permission to communicate directly with the password manager that Google has and grab all your creds. And then they'll do the same in Opera. They'll do the same in Firefox. They'll do the same in Brave. They'll do the same in whatever browsers you have installed. They'll take all those credentials and throw them in there. And then they'll also have cookie files they steal from your desktop, which I'll show you, or documents or downloads. Did I miss anything here, Jason?
No, Nick, yeah. one of the things that I get asked all the time when I talk about stealer malware and stealer logs is, well, does my password manager protect me because it's an extension inside of Chrome? So I wanted to throw that one up to you because it's absolutely one of the most common questions I get from other CISOs and even technical people, right? They don't know how much access that malware has to the system when it comes to those password managers.
Yeah, great point. So the stealers, something I don't have represented here, is stealers will grab everything they can from installed browser extensions. Now, each stealer, usually the affiliate, the person who buys access, they're able to customize what their executable will do, or what the download from their payload will do. And they can check off a box that's grab Chrome browser plugins. And so they'll grab all the configs of those Chrome browser plugins. And their options are mostly crypto. Like, do I want to grab crypto wallets? The next option is password manager configs. And then the third option is TOTP configs, which is like if you have two-factor enabled, TOTP is time-based. All they need to know is like the algorithm you're using and a couple other things, and they can use any old TOTP token on their own, recreate your exact profile for your TOTP token. And if you've got two-factor using time-based one-time generation, then they can take over your, then two-factor has been nullified by that. And then there's other extensions that are less popular, but the cookie or the password manager extension is important because if you save your password manager master password to Chrome, boom, it's been stolen. And if you're using a cloud-based password manager, it's going to be relatively easy to get into that. But another important thing is what a lot of people do is like, say you have the KeyPass browser extension that communicates with your local password manager. You've got a KDBX file in your file system somewhere that it knows to talk to. When it grabs your file if you've stored that master password to that browser extension in any other browser extension that it can grab, or in your Chrome password somewhere, or whatever browser you're using, the stealer will grab your KDBX file also. It will go into documents or downloads or wherever and grab your KDBX file, your raw password database, and then it'll grab the password from your browser plugin or from your browser-based password manager. And now the fact that you're using a password manager has basically been nullified.
Yeah, that also is pretty important because last year we had some password managers get breached where master passwords were kind of some of them were disclosed, not all of them. And then also it comes into play too, I think, at least when I talk with people generally, is a lot of people reuse passwords, right? So if they do grab, a local password manager file and they're trying to authenticate against it, they will also just try everything else that's in that passwords file from the browser. So reusing passwords is not a great practice because it could compromise everything else.
Totally. Yeah, you shouldn't know your passwords. That's they should be so unbelievably complicated that you have no idea what they are.
Yeah.
Okay, Jason, can you talk us through a little bit the basics of session takeover?
Yeah, absolutely. Okay, so on top of being the field CISO for Flare, I am also what they call a red teamer. I do red team assessments, which is I target organizations. They pay me to, obviously, I'm a good guy, but they'll pay me to attack them and try to get in. And so grabbing session tokens is one of the most and first things I'm looking to do, and the most exciting things I do. in the red team world these days for a modern threat actor, right? I think Nick mentioned it pretty well earlier. Why would I spend all the time of trying to phish someone at an organization or try to exploit them or even do like a physical attack, like dropping a USB key in the parking lot or something like that, when I can just go to these marketplaces and just either download for free or pay for access to a whole bunch of people who are infected with Stealer malware and just search through all of those and be like, cool, here is my target organization. There's a username password there for an employee. Let's just grab that and log in. And so for me, as a red teamer, having the usernames and passwords is awesome. But these days, most of the times you have a lot of security mechanisms that are protecting modern organizations. Now, not everybody's there yet. Not everybody's deployed things like multi-factor authentication and impossible travel alerts, and browser based EDR functions and everything like that, and even EDR, which is fancy name for antivirus on your machine. Not everybody has that, but the kind of customers I work with a lot of times do. And so you'll have the Stealer logs, and the Stealer logs include those session tokens. And so what I can do is that session token represents someone who's already logged in, already done the MFA bypass, and there's only a few security controls after that can really catch me as a fake bad guy. And so what I'll do is I'll go to the database, and in this case, I use Flare. It's why I'm with Flare, is because I use Flare. And I would go into Flare and grab these packs and take the cookies out. I'd search through everything, and then usually I'd hit multi-factor authentication when I'm trying to just log into the target organization. So whatever company we want to make up here, acme.com. And normally when you're a red teamer and you look at it, you'll get hit by multi-factor authentication. You'll be trying to look at a web page and it'll pop up and say enter your Microsoft credentials for acme.com. And you'll have a username password, and I'll try that, and then multi-factor authentication pops up, and I don't have that, right? I've basically downloaded these credentials off the internet in the dark web. So at that point, what I can do is I can take the session token from that Stealer log and inject it straight into my browser so that it looks like I'm you, and bypass multi-factor authentication completely. So I don't need the username password, and I don't need the MFA. I've already just said, hey, I'm this employee, and I'll try to walk right in. And so that's session hijacking. There's multiple ways to steal people's sessions. I could attack the employees directly by phishing them, but this is by far the easiest way, is to go to the dark web first and just see what's out there already for my organization. And the bigger the organization you are, the harder it is to protect this, because you have so many employees logging in from personal devices, from corporate devices. You never know what opportunity they have had to get malware on their systems for some reason or another. Maybe it wasn't even them, as we've referenced before. So yeah, that's what I'm looking to do with session takeover and hijacking.
Awesome. Okay, let's. I think the next part is a demo. Yeah. Okay.
Oh, nice.
So I'm going to show you what a session takeover actually looks like live by performing one. So let's pop open a little flavor of Linux VM here. So let's take a look at a Stealer log first, by the way. So I showed you all of those folders. I took a real Stealer log and anonymized it here. But this is exactly what, and by the way, we're going to use real cookies, but they're from a fake account I set up. These are not actually the victim device's cookies. But these are all of the files that a Stealer log contains. So let's take a look at what they actually look like. User information.txt is all of those recon command outputs I talked about. So we'll have an advertisement usually at the top, like a banner for where the Telegram channel you got these from, or the marketplace, and it'll be like, come visit us here for more logs like this. That's in case people share them around, so people know where they came from. We've got the IP of the device, which is great. We can geolocate this back to a region. We've got a country code. We've got a zip. We've got a hardware ID for the device. And then we've got some things that the browser uses when it's kind of footprinting itself to the service. There's lots of different ways it does this. But we've got screen resolution. We've got the hardware profile of the device, how much RAM is installed, what processor it's running, what graphics card it has, anything else here. The available keyboards, that's going to be important. And then we've also got some interesting information like the AVs installed. Now, when we open the passwords.txt file, this is what it looks like. Every time without fail, it looks very similar to this. Some slight formatting differences between the different malware families or sellers. But we've got our URL here for whatever the site is we're logging into. we've got the username, the password, and then the application that it was stolen from. So Google Chrome default means this was like the default profile on Google Chrome, and these credentials were taken from the user's password manager on the device.
Sometimes they're not nice enough to include all of them in the same passwords file. Sometimes you have a passwords file for each browser that the user uses, and then you have to go into multiple files. It's a pain.
Yeah. And then in File Grabber, I've got all of the files that were taken from the device. In this example, I just have 2. The person's notes. It's totally normal to store your notes in a markdown file. This person's notes, use my password manager to generate safe passwords. So actually, in this example, I have this is I'm saying their password manager database, and then within their passwords.txt file, I have their browser stored credential for that, which we won't go down that rabbit hole for this. We'll do cookies, but just to demonstrate that that's common.
And I have heard of newer variants of malware targeting a lot of productivity tools like Obsidian or Notion databases, since they're hosted locally sometimes by people, and sometimes people putting in passwords in those, thinking that they're just collecting their kind of passwords in there and looking through those. Yeah.
So what I'm looking at here is very common for the cybercrime world. This is called an anti-detect browser, which basically just lets you launch a browser, launch a web browser with whatever footprint you'd like, and be very, very specific about its configuration. This is a tool that like marketing teams, SEO teams, advertising teams will use, but it's also a tool that's exceedingly popular for the consumers of Stealer logs, the actual threat actors themselves. So what I can do in a anti-detect browser, GoDetect is paid. Honestly, I don't know if GoDetect is an anti-detect browser. I only know of a handful that I've used: GoLogin, OctoBrowser, Simple Login maybe. But they're all paid. Like I'm on a free trial here with a burner, but so many anti-detect browsers are paid. I've seen open source ones, but I've never used them because you can kind of reliably get a trial for what you need it for. But gotcha. They're mostly paid. So what I can do here is specify everything I'd like to about my device. What language packs are installed? What time zone do I want my device to be reporting in from? What geolocation? And this I can customize, right? I can proxy this through somewhere else. So I'm going to look in my user information file, and I'm going to find the geolocation of this IP, which, spoiler alert, it's the same geography as I'm VPN'd into right now. So the idea here is I don't want to look like I logged in yesterday from San Antonio, but today I'm logging in from, Poland. I want it to look like I want to lease an IP close enough to the location of the victim device that it looks like I just went to a coffee shop. And then whatever, heuristics engine they've got running to detect anomalies in active sessions, it's not going to care. It's going to let me in the account. Maybe it'll find out later that I stole it through what my activities are, but it's going to let me in because it thinks it's not going to inconvenience. It's not going to give me bad UX because I switched IPs, even though I'm in the same geography. And then I can also specify things like the hardware profile installed, the screen resolution, the number of threads of my CPU, and all kinds of other things, just so that the footprint of the device looks exactly the same to the browser when I get there. Now let's run this one. So this is an example that has nothing configured. I didn't put any cookies in here. These are Temu.com and Google, just because I already visited the sites in this browser. But if I go to Temu.com here, there's nothing. I'm not logged in. I chose Temu, by the way, because I don't think anyone from Temu is on this webinar, so I'm not making anyone mad. But Temu has, you can see I'm not logged in. Once it lets me accept the cookies, which is kind of paradoxical. And because I'm logging in from a different geo, it's not in English. But you'll notice I'm not logged in here. It's asking me to log in. Now, if I go to, and I'll make a fresh one actually for this example. I'll create a profile called Takeover Example 2. I don't need to choose anything saved. I don't need to specify that many of these. I can pick the same time zone, but I think my device has already matched its time zone, at least my VM. So let's just leave it. We'll leave it based on my device. Browser extensions I want installed, no need. Bookmarks, no need. WebRTC, geolocation, no need. Advanced, Mozilla is fine. I could switch it to Chrome. I don't think it's going to stop me. Well, okay, look, we'll leave it. Well, that's just the user agent. So it's using Chrome 132, which is fine. Let's make sure the screen resolution matches 1440 by 1080. So again, I'm looking at the victim's device's footprint here. Let's do, and trying to recreate it reasonably loyally here. CPU threads shouldn't actually matter. 8 gigs of RAM. Yep, 8 gigs of RAM.
And while Nick is doing this, so this is kind of the more like accepted app. Go log in to build browser profiles and have control of what your browser looks like. There are bad guy versions of this where they can just load the files in from the Stealer logs and it'll auto create the profile based on what it knows from those files. So a lot of times bad guys don't even go through a lot of these steps. Sometimes they'll just like upload the Stealer log into this app and it will build the profile dynamically and launch against the target.
Yeah, those are called checkers, like cookie checkers. They're way easier to use. What I'm doing now is something that someone who wants to be more careful, like maybe an access broker or maybe someone who's just very specific is going to use. But let's get the right language packs installed here. We will do German, Switzerland, and DE. German, DE, German, Switzerland. Save. And now onto cookies. So you saw I was not logged into anything in Go Login. I'm not connected to this at all. But let's go back to that Stealer log. Let's open the cookie file. And these are stolen cookies from the device. I will import cookies here. I will drag and drop that file, the cookies file. I'll have to edit it a little bit. I'll rip out this Netscape cookie format little notification at the top. We will import them. Now all of those stolen cookies are imported here. All I did was literally drag and drop that file. I'll create profile. I will launch it. And assuming I grab the right cookie file, if not, I'll grab the other one and test it. But if we run this, let's go to teamviewer.com. Boom, I'm logged into this account. I have not logged in. I've seen no login pages at all. All I did was drag and drop a cookie file, and now I own this guy's account.
Hey, look, there was a security reminder on the front page.
Yeah, there's a security reminder saying avoid scams.
Yeah.
Unfortunately, this gentleman has not avoided scams and got a Stealer, and now I have his account. This is, again, a fake account. So I can now go to my profile. I can pull my payment information. I can find my address and phone number. I can just start buying stuff and add an address in here. Now you know how easy it is. So there's all kinds of examples. I could pretty much have done this with any service the device was logged into and been able to resume it just fine for the most part. Again, pretty much unless the session was expired because they haven't logged in recently. So will a replay be available? I think so. We will check. Eunice, maybe you can verify that. But, oh yeah, this is what you were talking about, Jason, checkers. They make life for bad guys a lot easier. Instead of all that stuff we just did, they will just drag and drop the cookie file into this, and it'll go check on your behalf. And also, this will let them load in a gazillion of them at once. So all of the devices, a lot of this is kind of maybe a little more recent, which is Stealer channels also sell their ULPs separately and their cookie files separately. So they'll have a cookie sales, channel, a ULP sales channel, and a full-blown log sales channel. Each one offering unique value. So, Jason, you want to take us through why credentials are a little more challenging for bad guys?
Yeah. So, as I talked about before, if you buy, usernames or passwords, or one of the things is that a lot of people are familiar with services like, Have I Been Pwned or something like that. It's very ubiquitous now to know about Troy Hunt's project, where he keeps lists of breached data online, and that's usually sets of usernames and passwords. And you can go look up to see if your username and password has been leaked. But these days, everyone, I would say at least 80% of the planet, maybe 75% of the planet, as far as websites on the internet go, they have two-factor authentication enabled, right? So if I just grab your password from a data breach, and I have a username and password, even if it's valid, I'm going to get I'm going to get stopped by two-factor authentication. Now, also many newer school type of protections also do things like Nick talked about. They will look at where you log in yesterday to where you log in today, and if you're logging in from a geolocation that's very far away from one that you normally log into, they will flag that and basically flush all sessions. We call it flushing sessions, but really it's just they'll delete that session token, or they'll delete the server side reference of your session, and then you'll have to log in again. So the cookie is no longer useful to you, and the username and password is no longer useful to you because normally they have two-factor authentication. There's also the idea of trusted networks, which are networks that you log into all the time from. So like my home network, I'm sitting in this office. When I log into Flare, it knows that this is my home network. And if you have tightly tuned security policies at an organization, then anytime you leave your home designated network, they will make you re-log in. So there's a bunch of security features these days that modern applications have to stop you. They go even crazier. There are things that look at your mouse usage and your keyboard usage while you're on the computer to tell if you're a human rather than a piece of automation, like a script or some of the stuff Nick was showing, like anti-bot protection. There are so many security features this day, and it's really up in the air depending on how big an organization is what they can afford to implement really a lot of these days to stop bad guys. But a lot of us are working when we're protecting organizations, we're working with the basic tools like usually the first one we talked about, impossible travel and two-factor authentication. So sessions with the cookie, right, can bypass multi-factor authentication, because the way this works is that I land on Temu, like Nick was showing, and I log in normally when I'm going to that site with my username and password. And then I get the session token back from the web server after two-factor authentication. And that's my, multipass. If you're going to use a nerd reference, right? That is my passport to get into the website. And it is already that me having the session token indicates that I already have done all of the hoops to log in. And so, so this is why, as a red teamer or a bad guy, getting access to credentials is cool, but getting access to cookies is way cooler and way better for your attack scenario. So, yeah.
Awesome. Question in the chat: does this also include the hotspot created cell phone devices besides home network? So, like if you connect over a cell phone hotspot.
Yeah. So those networks are like your 3G, 4G, 5G networks and your CDMA networks, right? They do have profiles built around them. So a lot of people will give those a pass. So if you're working off of a cell network, they'll give a cell network a pass. But still, if you're connecting to a cell tower in Germany rather than in the States, or the States rather than in Germany, that's still designated usually in a security control as an impossible travel alert. Especially if you did it in a time frame that's impossible, right? Like it takes me to fly from Germany to the States, or States to Germany. It's going to take at least 8-12 hours, right? And if you are logging in from a home network on a device profile, and then you're logging on the same device profile on a different network in Germany, even if it has like all the stuff enabled, all the security checks, it might trip. So
yeah. And I mean, like if the public IP that your device uses at the time of compromise, as long as the person like geolocates within even a relatively healthy region, their proxy or their VPN or whatever they use to connect through, as long as they are in a similar geography, they'll probably be fine. Whether it's a cell tower owned leased IP that your hotspot gets, it's still probably going to have some geolocation that you can recreate. So for ATO, Stealer logs have become exceedingly popular. They kind of always have been, but they've seen a certain rise in popularity as Telegram has made their proliferation super, super simple. And a lot of the breaches from the past year have used stolen creds and stolen sessions. Think all of the big Snowflake compromises. This wasn't anyone compromising Snowflake as a company. This was people compromising people's Snowflake tenants. Ticketmaster, AT&T, Santander Bank, a lot of these done by the same groups of threat actors, which kind of speaks to a rise of these kind of low-level extortion groups who love using Stealer logs, the credentials and sessions saved in them, to take over corporate resources that host data, download the data, And they don't encrypt it. They don't ruin your copy of it, but they say, hey, we have this data and we'll release it if you don't pay us. It's like the most low effort extortion ever done. The days of them having to maintain complex ransomware infrastructure or join an affiliate program to like deploy malware to hold stuff for ransom is kind of over now that it's that's far from over. I'm overstepping there, but it's a new era where extortion of cloud hosted data has become trivially easy now that people are logging in to resources more than they used to. So super low effort extortion is working, and little extortion groups that are just taking over buckets, private buckets, and downloading their data are making tons of money from just doing that. And we see a lot of these logs a week. Like per week, we see about 1.5 million infected devices. A lot of those contain corporate credentials. I think like we average about 7 million a year. It's probably a little higher now. And actually, this number is updated. We've got over 100 million Stealer logs ingested at this point in Flare. And if you want to think how many credentials and sessions are in that, it's to the tune of many, many billions.
So this is a question I get a lot, Nick, that I'll bring up on this slide is what is Flare's magic? And we don't release all the data, right? But you can think of us as in our teams and our technology as the monitors of the dark web, right? And these Telegram channels and things like that. And we have a dedicated team that it is their whole life to be CTEM experts and cyber threat intelligence experts who are monitoring these forums, these chats. We have automation that grabs all these things. We have people who maybe don't leave the office a lot and are pretending to be bad guys and getting these things. And this is the thing that attracted me to Flare when I wasn't even at Flare, was the depth of the data that Flare has in this regard. It was by far the best out there when I had to use it as a red teamer. And I had to benchmark every person who did this. So this is why, I chose Flare, because they had I call it the freshest data, but yeah, for sure.
Awesome. Thank you. And Chris, I see your question in the chat. Name of the category of browsers that allow for spoof users and config details. Anti-detect is like the broad category name here. Let me type it in the chat here. Anti-detect browsers. That is what people use to refer to these. So I'm going to ask you a question, Jason. Did you also try Kella?
I did. Yes. Yeah, I mean, so when you're a red teamer and you're doing this work, right, the first step usually is like, I could build this by myself. And then you quickly realize you cannot, if I'm just being honest, right? Like going out, grabbing all the torrents of first of all, the breach data, then infiltrating the Telegram channels, then creating burner accounts and staying active. And that's only, 2 levels deep into this ecosystem of bad guys. You learn very quickly you cannot do this at any scale, on your own usually. And so, I had to benchmark a lot of stuff to figure out how to give my clients, who are my red team clients, the best service. And so that's what I did, is I benchmarked everything. So yes, I did. And Flare came out on top in almost every case. But so I hope that answers the question.
Awesome. And I see another question from Ricardo. My only question with Flare: why don't you have a plan for people or groups of people like families? I think it would be cool. Good question, Ricardo. I'll consider that a feature request to add monitoring for families or people. Noted. Another thing I'd like to address is what our volumes look like per month based on services. Now, there's a million directions I could have taken this search, but I pulled these just recently, like at the end of the month. This is for January 2025. Oh, I left 2024 in there. Sorry. Not accurate. I was doing yearly at first. In fact, just for the recording, I will fix that. The January 2025 statistics on just super high level corporate assets. Accounts.google.com, we have close to 1 million leak creds on a monthly basis, right? This is just January of this month. And for sessions, we have a little bit more. This is super common. And in fact, the next one, which is Auth0, we have about 29,000 leaked creds and less leaked sessions. This is uncommon in that most services will have more leaked sessions than credentials, because leaked sessions Not everyone saves their passwords, but everyone logs into something. So whether you log, like everyone being logged in means a session is created. But just because you're logged into something doesn't mean you save the credential to your browser. Now, it's not as surprising because people might use corporate password managers to save their Auth0 password and not the browser's password manager. So that's why that situation does happen. But for aws.amazon.com, I could have done the same for portal.azure, about 21,000 leaked credentials. And there's a lot of people who use AWS for personal use, but there's a lot more people who are logging into corporate resources with that aws.amazon.com login. And then for leaked sessions, we've got more than double that at 50,000. LastPass, I try to cover all the bases here with like SSOs, collaboration tools, cloud portals, and then password managers. LastPass has about 4.6 thousand leaked passwords. So these are, because it's to the LastPass resource directly, these are probably master keys. And then leaked sessions to LastPass's web portal is 10,000, so just shy of 11,000. And again, lots of normal people using leaked credentials, or lots of normal people using LastPass, but also lots of corporate vaults stored in LastPass and all the other password managers.
So here's a question for you, Nick. The one that I get often, right? I'm just trying to throw you the ones that when I'm around the table telling people about Flare, like the first questions I have. Does something like Okta protect me in this context? Does a identity provider or a login provider prevent me?
Yeah. What IDP, so sometimes what IDPs do is make the life of a threat actor so much easier, right. Which is that if they can get into your Jump Cloud account or your Google account or your Microsoft account or whatever is federating your login, whatever is federating identities, where when you log into it, by logging into it, you get into a bunch of things. No, not necessarily. Now, what some IDPs and IAMs do very well is their session time to live will be super short. So the session will expire after 24 hours or after 8 hours, or like sometimes the admin configure it to be like 30 minutes, you get locked out. That's awesome. Now, the challenge is there are live Stealer log channels, as I suggested before, that will immediately upon the device's infection, it's not going to some backend where a guy's dropping it per day. Yeah. It's posted the second, right when the exfil moment, it's going straight to Telegram. So if bad guys open those, which they do, they have automations for pulling these into their own Elastic backends and parsing them out. They've got that session, it could expire in 2 hours, and that's enough time. They are automatically checking the session for validity and sending themselves an alert when they get an Okta login. So even super short session times can be thwarted.
So if you allow me a little bit of story time here. On top of being a red team, I've also been a career CISO for, probably like 10 years, at least in the security executive, the highest ranking security executive at many companies. And so I have faced, 1 or 2 breaches in my time. And everyone will, right? Don't feel ashamed about that. Like every company will have a time when they're going to have an incident that's pretty high profile. But I can tell you for sure that the stuff that you're seeing today is exactly how kind of modern threat attackers work, or threat actors work, right? So we, at one of my organizations, had a employee who during COVID went home and had to use his personal laptop to access some corporate resources. That machine had already been pre-infected by some Stealer malware from his or her kid trying to download some, I think it was Minecraft crack or resources or like something like that. Yeah. And so the malware had gotten on the machine, then the adult had logged onto the machine. And some of the attacks are a little bit more insidious, right? So in one case, the malware was on the machine, the Stealer malware, and it went up to the dark web, and it went for sale. And then a real threat actor bought it off of a marketplace, and we were able to trace it back to actually which marketplace sold it eventually in our investigation. And so you look at what the attacker did, the real threat actor, the real bad guy, wanted to do with it, and they grabbed the Microsoft cookies for the Microsoft web portal. And so what they did is they grabbed those cookies, and the first thing they did was actually just make life easier for themselves and changed the 2-factor authentication device to a burner phone of theirs. And then, so they had, even if the cookie wouldn't work or got expired, they still had the username and password, and now they had access to a two-factor authentication device too. So they really wanted to like CYA themselves, right, and make sure that their breach would that they still had initial access, and that was their initial access into federated identity for the organization. And that means that sometimes people use federated identity to let people log into VPN logins, which was the case for one of our organizations. And so then they were able to get into the VPN and get on the internal network. And from there, it's off to the races for most bad guys. There's not much that's going to stop them once they get on the internal VPN access. So there's a lot of little tricks that you can do once you steal credentials like this and stuff like that.
Yep. I see a question in the chat. How much of the data in the dark web you fetch is legit and not fake? So that's a really good question. We try to detect when a Stealer log is fake. Now, honestly, what's a much more common issue is that a Stealer log gets reposted like 10 times. Because one channel, like channels kind of will pass off if their volume isn't doing well, or just as something that they do as a regular old activity. They'll take Stealer logs from other Stealer log channels and repost them as their own. And logs fly around through these sample channels and get reposted into other groups. So one log, because we track where it came from and its location, we can find where it was first posted to. So we do have like a source of the timeline of a log being posted. But the odds of logs being fake, it certainly does happen. People will try and beef up their collections, their own Stealer log programs. If they have a campaign that's not going well, they might throw in some fake logs into the collection to beef it up. But again, we have detections where like we have like rules that run against logs that are imported to try and find interesting things in them, including, do we think it's fake? Do we think this Stealer log is not legit? And the volume compared to real is like, it's very, very low. I don't have exact figures, but in the world of Stealer logs, these campaigns that they run are so successful that they don't really have to fake much. It's very easy to get people to download things, especially when they're usually targeting video game modding communities or people downloading software packages unsuspectingly. They do a good job at hiding it generally, though sometimes they don't, and it's surprising how many successes they get. But okay, Jason, can you walk us through defenses, since you've actually defended against these things in real life?
Yeah,
that'd be helpful.
Yeah, so on a web application, when your primary product as a business is a web application, and you're protecting an organization, and then you also have, other than your main product, which is a web application, you have your corporate network, which is, you have an internal network which all your employees who go to the office work from, and that has all more private resources on your corporate network and stuff. There's a bunch of defenses, but a lot of times what you have to do is tune your session token lifespans. So the second bullet here in this slide, you have to tune this very aggressively. As Nick said, there's always going to be ways to attack users, right? That's never going away in the world of security. We're never going to be 100% perfect at it. And so these things will get exposed, but reducing the lifetime that they can be used against you is one of the ways that you need to basically be ready for. And so that means things like your cookies for your Microsoft ecosystem. A lot of businesses for their corporate, their corporate resources are Microsoft shops. Not all of them, but most of them. That means reducing your O365 cookies or Azure Services cookies or session tokens down to something like 24 hours or something like that. And that's what we did at one of my companies, and it was drastically useful, that technique of lowering. Now, what that means is if you're limiting the session token lifespan, that means that users have to log in again every day, every 24 hours, which is it can be painful from a user perspective. But we found that even with some of the automated stuff, it would take bad guys more than 24 hours a lot of times to access the cookie of an employee, then get it into the marketplace, and then sell it, and then somebody use it. It would take longer than 24 hours. So we had already rolled the session token and stuff like that. You can also just go through a database like Flare. We're going to talk about these methods in the next couple slides, but you can go through a database and find out what machines have been compromised, roll those sessions. But what you have to remember is when you go on, your web application or your corporate environment and you're rolling these sessions. And by rolling, we just mean expiring the session authenticate or the session token. When you expire that, they still have malware on the machine. So when the user logs in again, they're going to get the new cookie, and the new cookie is going to go on the dark web, right? And so when you see in a database like Flare, or anyone you use, I'll be agnostic, right? And you see someone who's infected by specifically Stealer malware, you have to think about a couple things. That device is at the computer level compromised, meaning that it needs a reimage. Most of the time, it needs a reimage just to make sure that it's going to be okay. You might want to up the level of EDR or antivirus on the machine as well, or make sure it's enabled or whatever. And then a lot of times what happens, and this is an interesting one I want to discuss with you, Nick, is that we find in investigations that, especially post-COVID, when people work from home or hybrid, it's personal machines that get compromised. And so you necessarily can't tell an employee to go reformat their personal machine, right? Even though they're using it for corporate work. So I'm wondering what you've seen in that area of advice. I usually tell people, some interesting things I've heard from other people and brainstorming at dinner tables and stuff is you can give them a stipend for computer work and every year or something like that, and they can go take it to Best Buy and get it reformatted, and you can just build that into a budget. But have you ever heard anything around that kind of dilemma?
Yeah, I mean, well, people are forced to share devices in the house a lot. The general advice that's wise is good hygiene, like log out of the tool when you're done using it, because one login to SAP or, again, Okta or Salesforce or whatever on your kid's computer or on a shared family computer is absolutely all it takes. So personal devices, really in probably our Stealer log data, orders of magnitude more infections are from our personal devices than corporate devices. But they've still led to myriad of infections. And yes, Evan, great point. Manage company endpoints. Keep them. Don't let them drift away from configs, and actually prevent people from visiting malicious things on them. Man, there's so many good questions on the chat I want to get to. But
let me blow through a couple more of these. So your Microsoft ecosystem for protecting your corporate LAN usually comes with tunable dials. I call them dials, but they're just configurations in your administration section of basically your Microsoft ecosystem. So unusual session activity, we've talked about one of those. It's called impossible travel, is now included, I think, by default in all Microsoft packages. So turning that on and tuning it well. Support session invalidation after 24 hours, and then also after people change passwords and validate the session, so that they have to do new things every time a password is changed or a device is added. Trusted networks is one we talked about before. So it's not in this, but it's related to device-based session. But there's a trusted networks option as well in the Microsoft ecosystem, so that they can only do things like change passwords, add two-factor authentication, or get to certain resources from trusted networks. And then device-based session validation. Everything that you log in from, like your browser. One of the reasons Nick had to use that browser spoofing application that he used is because every application profiles the kind of thing you're coming from. Are you coming from your desktop PC? Are you coming from your phone? Is that different than what you normally do? And is it coming from a new IP? And so these are markers as to, is this website going to trust you? And a lot of the higher levels of Microsoft subscription have tunable dials to say, well, if two of these markers seem bad, we're not going to let Nick log in. That is just too risky for our organization. So there's a lot of things you can do in different ecosystems, not just Microsoft. All of the identity providers have these tunable things as well. And so these are the type of things your admins are and your security people should be making sure that you're looking for.
Yep. So the next option obviously is the Flare one, which is finding stolen sessions at the source. So what Flare does, and this is an offering that we have called ASTP, which is Account and Session Takeover Prevention. And basically what we do is take all of those stolen sessions and stolen credentials from all of those communities, all of these cybercrime communities where they exist. Our collection is quite massive and growing by about 1.5 million devices every week. And we allow you to search on whatever web resource, whatever apex domain, whatever URL you'd like to find those leaked values. So this is an API product, though it does have UI components that you're allowed to use Flare to do the same things you do over the API for validation or to investigate a Stealer log. But this offering is built specifically for pulling leaked sessions by domain and pulling leaked credentials by domain. So we're not just finding, if you're companyname.com, you can search up with many tools and with regular Flare to find leaked corporate accounts. The idea behind this offering is when you look up companyname.com, we are showing you all the logins to that portal, assuming there's a login portal on companyname.com, and all of the leaked sessions for people who are signed into companyname.com. So this is to protect users, this is to protect employees, and this is to protect customers of web assets or web resources that you own. So I've covered our data already. We collect all of these stolen devices from all of the places that they exist online. We make them searchable. Where we sit in the sort of path of ATO detection is between the logs and the bad guy actually taking them over. So most ATO tools, the majority of these suites live in the once someone's taken over the account, how do we find that they have by recognizing their behavior? I saw someone mention TLS fingerprinting in the chat. That's a great example. There's a lot of different browser fingerprinting or network activity fingerprinting techniques that people use to find leaked and popped accounts. And there's tons of good research into that that these tools will use. However, usually those take action after the session is being used. It's already been taken over. And it doesn't take much to find, the crown jewel in a stolen SSO portal. So ASTP will help you stop the sessions from being taken over in the first place by showing you the stolen sessions and stolen credentials from the same exact marketplaces that an overwhelming majority of threat actors are using. They are not compromising devices mostly on their own. They are mostly taking sessions and credentials from these marketplaces directly. There are obviously threat actors who will, detonate malware on your device and steal cookies that way, but it's much easier to not do it. And everyone, we see activity from ransomware threat actors all the way down to fraudsters and all the way up to extortion groups who shop directly from these marketplaces. So it's to us the most confident place to find stolen sessions. The way it works is very simple. You query our API and we respond with the sessions that we know have been stolen and the credentials that we know have been stolen for that portal, along with information about when we found it, if it's still active or not, if it's expired, all the metadata we can, and then you can use Flare to investigate the device. And then on your end, you'll need a mechanism to verify the cookie's validity, see if it's still active on your end, and then revoke them. But also in the revoking world, we've got some things we're working on with Entra ID. That'll be our first target for automation, where we will automatically cycle out credentials or sessions we find leaked for that service, and we will slowly but surely move on. Well, hopefully not that slowly. We'll move on to all of the other SSO providers and major web resources. And if you've got a large-scale web app you'd like to protect, or SSO portals you'd like to protect, we can certainly help you automate the credential rotation and session rotation on those services as well. So that's it. I'd love to open the floor for questions, comments, and we'll read through chat now and see if there's anything asking that we did not get to. This webinar is great, especially for blue teamers who have no practical experience dealing with these dealers. Yes, thank you, Edward. Someone asked, I remember the torrent of video games. Flavio asked, I remember the torrent of video games and free voucher coupon sites were popular for malware spreading. What's more popular these days? Now I would say Google ads that have been they're just malicious. They're malicious Google ads, sponsored website links that will perform relatively well on SEO. And then honestly, YouTube videos like free Photoshop, free Discord raid bot, free Microsoft Word, cool new AI tool, free ChatGPT, free whatever, or free mods or free cheats or free video game trainers. In the comments, they've got a Mega NZ link. They've got a link to some external download, and those are super, super popular now for spreading malware. And it doesn't help that a lot of young software engineers who have access to all kinds of company resources also love to play video games. So that's a common place to get popped.
Yeah.
Do you have any playbooks? Yeah. Go ahead, Jason.
Oh, I was just going to say, so in the last section, Nick talked about kind of like the use case of your web application or whatever. We actually work with a ton of really big gaming companies, and selling video game accounts is a big thing. And so, and I used to work in the video game industry, right? And so a feature like that could help our user base from getting their accounts taken over is really important to us. And that's actually really important too, because, you know, last year 23andMe was a big deal where for a while 23andMe looked like they had a large data breach. And it actually wasn't a data breach. It was a targeted release of basically accounts that came from the kind of stuff we're talking about today, but it was a mass pack. And so they thought they had been breached, but they actually hadn't been breached, turned out. And it was just a mass pack of basically consumers of theirs, customers of theirs getting popped. So, you know, taking care of your customer base is also just as important as taking care of your corporate, you know, user base as well. So
awesome. Ricardo asked, do you have any good playbooks for the defense part? So yeah, we actually work with several SOAR tools where we'll like help our customers configure playbooks to do these things automatically. And if you've got a SOAR tool you'd like us to work with, let me know, and we can certainly try and make it happen. And then also now what's important to us is working directly with your auth system. So if you've got a web app that you run that you need automated rotation into, you know, we'd love to help get that set up as well. Help your dev teams, you know, show them our APIs and help them get comfortable with using them so that they can automatically deauthorize sessions in web apps. But again, we can do the same in corporate portals and in SSO portals. Awesome. Well, thanks again, everyone. We really appreciate it. You can find us for more questions in the Flare community Discord, which you can join from a bunch of different links in a bunch of different places. And if nothing else, we can also be found by email on LinkedIn or wherever else you'd like to reach out. So thank you all so much, and we'll see you on the next one. Oh, I forgot the announcement. We have another webinar next week where we will focus more on end user protection. This was more of a corporate focused one, but the next one will be on doing the same kind of detections for end users, and we'll dig more into those APIs, and I'll show you examples of what they actually look like to interact with. Do we have an ETA and Enter ID integration? I do. I will. I don't want to announce it on the webinar, but reach out directly, Jason, or I'll reach out to you and we can chat about it. Cool. Thanks again, everyone.
Thanks, everyone.